In the last section, we looked at what we could find out using the M+1, which was caused by carbon-13. Now we're going to look at an molecular peak +2, and it's going to be caused by different isotopes of chlorine and bromine and other atoms, but we're only going to talk about chlorine and bromine. So in nature, we find that 75% of the chlorine is chlorine-75, and the other 25% is chlorine-37, which has two extra neutrons. And what we'll see, this is the molecular peak, and this one that's 2 over is the molecular peak +2, and it's caused by the compounds that have chlorine-37 instead of chlorine-35. So these all have chlorine-35. Okay. So we can also look at the same sort of effect with the bromine. The bromine isotopes are basically split. Half of them are 79 and the other half are 81. So this peak is our molecular peak, and this other peak is our molecular +2 peak. This molecular peak is the compounds that have bromine 79, and the other peak has bromine 81 in it. So let's look and see if we can identify this pattern. In this first one, we see a molecular peak here and a molecular peak +2 here. They're basically even, so we would guess that this would be a bromine. Here we see a molecular peak, and 2 away we have a molecular +2 peak. We can see that this one is about 3/4 and this one is 1/4. So this is a chlorine. This molecule has chlorine in it. These two don't have anything really at the M+2 position, and so we would say that they don't have either. None.